Hey again guys, and welcome back. Those of you who have been watching this channel for a little while know that I've been collecting parts to build a water cooling system for some tech and some LED experiments. Well, today is the day. I think we have enough parts in stock that we can start building it. So yeah, I've got this scrap of MDF here. I think this will be the base for it for now. We're going to build it together in this video just so that we can give it a test, make sure it works, and then maybe we're gonna throw a load on it and see how much it can dissipate. So yeah, let's get started. I've got my scrap wood here. I've got my radiator here. It's got the deep cool fans already on it, which is fantastic. I've got my water pump, and I think the plan is I'm going to start with these pieces. I think I'm going to go something like this. The bungs go on this side. I think I'm going to put this somewhere centered about like that, and I want the pump somewhere like up here so that it's at the highest spot because it has the reservoir in it. So I want that up like so, and then the hoses will come out this way, and basically you should put basically it should pump into the hot side. It will be the upper side, and then circulate to the lower side, and then to the LEDs, and then back here into the reservoir. The cool part is it doesn't really matter what order you put it in. The thermal mass of the water is enough. That doesn't matter where the reservoir is in the loop. It's just that you want the hotter end on the top of your rad so that the bubbles don't get stuck. Now, to mount this onto this piece, I have 3D printed some parts. These guys here, these are self-designed, and they will sit somewhere like so. And so I'm going to get some M3 screws, and we can start assembling this. I've got some M3 hardware here. I've recently organized my hardware. If these are long enough, these will do. They are not quite. Very few threads in there. These long enough? These might be a little bit too long. So I'm going to have to pair these up with washers, but I think they'll do. So these feet were designed in Fusion 360. I'm loving Fusion. I'm glad it's free for individual use. I have Corel CAD, but Corel CAD is really difficult to use. I bought it on a charity humble bundle. It's just it's not ideal. I'm actually going to mount these a little bit loose, and then when it's screwed down to the board using these little mounting holes here, then I'll secure them tighter. 3D printer is still running fantastically, which is good. Don't know for how long, but yeah. I do have some plans to upgrade it in the near future. If all goes well, these files will be available on Thingiverse. If I didn't design them particularly well, however, then I'll have to postpone that until I can design a better version of it. Okay, that seems good, and if I pop this down onto the mount, yeah, that should work. That should work just fine. And I've decided to route the hoses on this side here, so the reservoir will be around here. So yeah, not too bad. You have to be careful that these screws don't go into the tanks. I don't think they do. No. Okay, good. Alright, gonna get a power drill, and I will screw in these mounts. Got some holes pre-drilled into my base plate here. I pre-drilled them because the salvage screws I'll be using don't have very pointy ends to them. And I suppose pre-drilling makes stuff go easier. That's not really why I did it though. I'm going to line this up think I bent one of those over. Well, that was a pretty epic fail. I twisted these apart, twisted a couple of these apart, and the rest of them I just stripped out. But at least it's holding sort of okay for now. Next step up is we're going to use some double-sided tape, I think, to hold this on. I sort of wanted it central like that. Maybe I will put it central and see if we can get the loops to work out. So yeah, if I put it on the top as it cools, it's going to want to come down to the bottom. So it's going to be out like this to the top, then this hose on the bottom out to the load, from the load to back to here, and then the reservoir up here at the highest point so all the bubbles don't get trapped. And I can just use some double-sided tape. This is like foam tape, and I think this will be just fine. I might shore it up with a little bit of hot glue. I'm not too worried about this stuff holding super well, because this is more of a proof of concept, and if it doesn't work, I'll just, you know, shore it up with something else. It's fine. This will be mostly just hanging out there, sort of doing nothing, so I don't think there'll be too much loading on it. Plus this this tape is actually pretty good, double-sided tape. And I also wanted it because it will eliminate vibrations if it's foam tape. Because you can get carpet tape, which is very sticky as well. There we go. And this I'll just stick sort of right up like that. That's not going anywhere. That's pretty sweet. Gonna put some plumbing fittings on down here on these 2 points. In fact, I'll probably tilt it this way. It's kind of leaning on that pump there. Maybe I'll use one of these. There we go. Now I'll just put these 2 fittings on. We'll run a little bit of hose. We'll do a little bit of connecting for all these powers and grounds, and then we should be good to start filling the loop. Got my parts here. So these are some metal fittings that I had to pay a lot of money for because I thought I was making this project a lot sooner, so I bought them on Amazon. They are a British thread. They're not regular NPT, and that's why they're a little bit specialized for the task. And I could go out to the garage to get a wrench, but you know, it's snowing out there. Why would I do that? I'm just going to secure this. I don't want it to be any level of extreme tightness, but I definitely want it pretty tight. It does have an O-ring, so I don't think they need to be torqued. They just need to go down seat and push the O-ring down. Squeeze it into its hole. Whoops, really trying not to ruin the chrome finish. I purposefully left a gap underneath the rads, if you see there. And that's to run wires under. It probably won't get a super clean wiring job this video, but certainly in the future it's going to be nice and clean. My main concern with all this is that I actually should have gotten a triple rad setup. So I'm hoping that this is going to be fine. But yeah, this is going to be the cold block here, and that'll be sort of free flowing. And this is what I'm going to mount to something, clamp onto something, and this is where we're going to put our LEDs, or where we're going to put our techs. I specifically bought it so it's big enough to have 2 techs on it, so if I really want to, I can go and pump a lot of cold. So yeah, not really liking how loose this is here, so I might put a bead of hot glue there, and we can run our tubing after. I'll bring you back after that's done. Okay, gotten this far. I'm still wondering if I should go radiator first, or if I should go like right from this, get the coolest water to the reservoir, but I think it's better to go from here out to here, from here to the load, which would be this, and then back in through there. So basically the water will get chilled, sent out to the load. Yeah, I think that's the way to do it. So basically this is the outlet of the pump, so I need that here, and then I need a nice big enough loop here so that I don't kink this hose at all. So it'll go through here. Actually, hottest portion usually goes on top. See, this is where I run into the problem. If I go too tight of a bend, it starts kinking, and this is a complex like S curve here. It'd be a lot better if I could go to the bottom of the rad. That might not be a good idea. Let's see. Can I go from the... See, I can go from the bottom of the rad to there pretty easily. Yeah, I might do that. From to the load, and from the load, and then this will be at the rad here. I'll put a little bit more length in it so it doesn't kink. And snip it using the mystery patron scissors. There we go. Now I've got come on, get on there. I've got 2 clamps that came with the pump, but I think I'm going to end up using zip ties because I need more than just 2 clamps anyways. There we go, that's slid on there. Okay. And so this to the load, from the load. There we go. Got a little bit of a kink, but it should be okay. Once it fills up with water, it'll kink a lot less. And now I need some zip ties. Thankfully, another maker had sent me a whole bunch. Just gonna grab a handful of these. Now these have a barb on them, so I don't think they're going to leak, but just in case the zip ties are there, use some flush cutters to cut these flush so I don't cut myself, like that. Same thing to here. After that, I have to figure out a mounting solution for where the load is going to go, but I don't have to deal with that quite today. This is, I just want to get it working, get the bubbles out, and see if we can get something going here. There we go. That part is done. Now to the load, from the load, I have quite a bit of hose left, and I don't see why I wouldn't just use the rest of it, aside from the fact that it won't be very compact. I think it's just good to have as much length as possible so I don't have to plan out, and plus, I mean, if I need more hose, I'll just order more hose. This is not a big deal. So on like so. And then onto the load. That one is very loose. I might put 2 zip ties on there. And then from the load, back to the rad. Top of the rad is the hottest part, so it'll help the circulation. It'll help because the heat, the hot water will want to come to the top, and the colder water will want to drop down naturally. So if you use that in the same direction of your, if you flow your pump in that direction, then you'll have that helping you instead of hindering you. There we go. Another one here. Whoops, a little kickstand fell out. Pretty excited that I'll be able to test high power LEDs. I've actually ordered a bunch of 100-watt LEDs, but they never had come in. They've always gotten sort of lost in the mail. So I'll be thrilled to order some more and have them actually come in. But I also have some little bit lower power LEDs that do run from 110 volts AC. And as long as I can find a way to jerry-rig a ground wire onto this thing, I think that should be just fine. Hopefully that'll be enough. Those techs do get really hot. And that is it. Should just do a little bit of wiring, and basically it'll be getting 12 volts over on these 3 connectors, and then that's it. Should be able to start this and have ourselves a working pump. Hopefully this is all watertight. So let's get that done and I'll bring you back. Got a few pairs of pin headers here, and I'm going to try to fit this all together. I don't know if I'll manage. Can't see from this far. There we go. That should do. Just going to give it a touch of solder, and then I'll have to solder a wire in between them. Now, you can solder these holes together, but you know, it's a pain in the butt. And I think it's a lot less of a pain to just solder a wire onto there. Got myself some wire, and I've peeled all the insulation off, and why I decided to do that with PVC wire instead of silicone, I will never know. But it took me forever to peel the whole insulation off. So I'm just going to tin the edges here, and this will be the sort of the positive and negative connections here at the ends. That's why I picked this kind of breadboard, or PCB thing. Alright, so I'm going to solder on to probably here and then go all the way across. So this could get hot. I'm going to maybe start at this end. There we go. Gonna let it go before it gets too hot. And then pull a little bit of tension on there. And this will probably burn me. That was not too bad. And then now I can just solder onto all these points here. Solder down. Oh, don't know if that one worked. Oh yeah, soldered in place there. That's good. This one here. And now that it's tacked, I can actually solder these a little bit better. This side and this side. There we go. Chop off the excess. And I'm going to inspect. Yeah, it seems to be all soldered. I can do the same thing on the other side. Now all we need to do is strip some wire and arbitrarily choose a positive and a negative. Take the short end, solder red here, and black here. There we go. Should be able to peel this out of the breadboard now. And there's our parallel connections for the power. So that should be just fine. Now I guess it's time to fill it up and test it. So let me get it all onto the bench and I'll bring you back. Okay, so we can see that this side here is red, which is positive, which means the other side will be negative. So we'll just bias our connectors over that way. Typically the third pin here is just to sense the speed of the motor. So we don't need that in our case. Here on these connectors, this one here, the power's on the outside, ground's in the middle, and ground is indicated by this white line. Not sure if you can see it, but anyways, it goes into the center here. So ground is there. Okay, so it goes this way. So yeah, this is the same connector. So yeah, that's essentially it. It just biases towards this way. There we go. That's all hooked up. We can give this a test to see if we can get current to flow and the fans to work. I'm just going to move it this way so maybe we can see the lights from the fan. Turn on the power supply and go up to 12 volts. Not sure what the current limit is, but it doesn't really matter. And the pump's going to make a crazy noise here. So there you go, fans are running, pump is running. Not good to run a dry pump, so I'm just going to leave that unplugged for now. And then this guy here, that's the aluminum block. I have no way to heat it up really, but we're just going to fill up the loop and then we're going to figure out some way to test it. So normally in these loops you need to put, whoops, this positive still live. Normally in these loops you need to put distilled water. I'm not too worried about it. I'm just going to empty this loop when we're done today and probably go get some distilled water for a different day. So for now, the goal is going to be first of all to see if we have no leaks. And then second of all, it's going to be to see if we can cool something with it. Could make a mess all over, hopefully not. Oh, a little bit of a mess. Oh well. There we go. As the pressure increases, the water will travel down. Or not. You might have to just give this a tappy tap tap. There we go. I feel the wind blowing from the fans. Pretty crazy. Oops, another mess. Is any of this in shot? Oh yeah, it's all in shot. Good. There we go. Aspirating a bit of air. That's okay. That's ridiculous just how much flow there is. Okay, I think it's at the point where I can just run it continuously now. So let's do that. There we go. Just gonna sop up a little bit of the water mess I've made. So it's got to work out its bubbles. It's not going to be quiet until it does so. Just going to top it up all the way. There we go. We've got a closed loop. I have no leaks that I can see. And that's going to be almost its final loudness. So not super quiet, but not super loud either. Just needs to run all the bubbles out, because there's a lot of bubbles stuck in the trap in there. But that's not bad. Got it working. There is a lot of airflow coming through. It's going this way across the bench. There's a little bit of a kink here, but let's see if I can, there we go, can kind of straighten it out. That's good. The rad is slowly losing its bubbles. Just going to move it around a little bit. As long as we don't get the motor portion of the reservoir to empty, should be good. Does look like everything's sealed. I mean, these are all computer cooling parts, so they should be reasonably waterproof, or the seal should be reasonably good. It's not a guarantee, obviously, because they are the cheapest parts I could possibly find. But yeah, this thing here is a nice and cool, you know, about the temperature of the room. So that's pretty neat. So the next step would be to put some sort of load on here, thermal load on here, and see if it holds. But honestly, I don't really see any way that we're going to increase this water temperature without expending a lot of current. So maybe I'll look for something fun to plug in. I don't know. I'm going to go take a look. Okay, here comes the test. I've got this multimeter hooked up to a thermal probe underneath the cold block here. I've got a huge parallel load here. I don't know if my power supply will hold on that one. This one here, the temperature is in Celsius up top here, Fahrenheit in the bottom there. It is not adjustable. So that's the way I have to go. Now the temperature is probably more closer to the same. However, these are the probes I have and this is what we got. So just look at the 15, 16 as a starting temperature and the 18 here as a starting temperature, and we'll see how they go up. So I'm going to turn the voltage up here, and I don't know how much current my power supply can handle, but here goes. I'm at 100 watts. I'm probably going to be losing a lot of current in these wires here. The power supply is singing. These resistors are heating up, but don't forget I've done these tests before and these resistors got very hot. So we'll see if it keeps up at all. I have 8 amps at 13 volts going right now. These resistors are getting hot now, but the water temperature has not increased. The power supply has a fan that's turning on. This thing, I have not tested this power supply yet, so things might be getting hot here. We'll see. So far so good. Still 19C here and 16C here. Now this is what I was saying. The water itself has a large thermal capacity. So I don't think we're going to be seeing a lot of increased temperature just yet. These might be getting... oh yeah, those are... so these resistors are now at the point where they're pretty much too hot to touch, but we still haven't gone up here. There's a little bit of air coming through the fans here, but honestly, the water temperature has still not risen a single degree. I'm going to try to go up on voltage. Something might give up the ghost. About 140 watts now. 15 volts, 9.26 amps. I mean, the water is still cold. The block is increasing in temperature now. The power supply fan is going nuts. Still 16 degree water. The water block still cool. If I touch it here, it's cold, but I can feel the actual heat coming off the resistors. 17C, we went up a degree here and we went up a degree here. So these are probably tracking to roughly the same temperature. I'm going to drop the voltage down. I'm going to go back down to 100 watts, let the power supply cool down a bit, and see if we can still pump some energy into this loop. My maximum recording time is 10 minutes, so I'm not going to go anywhere past the 10-minute mark. Just want to make sure I don't heat anything up too badly. So far the connections, the wires, everything's looking good. There's a lot of heat coming off those resistors, but the water is still keeping its temperature. Okay, power supply fan is turned off. I'm going to try to do another pull up. Maybe I'll try to get to 150 watts this time. Okay, slowly creeping up. 144, 153 watts. Still pumping that energy. And again, a lot of it's being lost to the atmosphere. I get that. But there's really nothing else I can do aside from putting a good quality thermal compound underneath there. So the power supply is doing pretty well. The connections up at the power supply are not very hot. There's 10 amps of current flowing through. The wires are starting to heat up a little bit. Should do this with thicker wire, but whatever. Okay, 21 degrees. The water temperature should increase as well. 17, 18, it's just going up there. I gotta let this get to 18 and then move back down to 100 watts. Let the power supply fan a chance to catch up. Moving down. Something smells like burning now. Not sure if it's these resistors. Oh yeah, they are damn hot. Water temperature has not changed very much, only a couple degrees. Still have an annoying kink here. I really think the burning smell is from up here where the power supply is and not from down here where the resistors are. So right now I'm at 96 watts. The power supply fan is turned off. Not feeling any heat on the box though. 21 degrees C, 18 degrees C here. Still another 3 minutes left on this, on the maximum, 3.5 minutes left on the maximum recording length I have on this camera. If you're wondering, the pump combo is pulling, the pump and the two fans are pulling 720 milliamps at 12 volts. This is certainly keeping up. This resistor is a slightly darker shade of orange than this one. I can still feel a lot of heat radiating off the top of that. But again, the the hoses, everything are cool, and this 18 degrees C water, no problem at all. Still concerned about the current draw, but doesn't seem to be a problem. I could put the power supply down on the bench here to just plug these bananas right into it, but it is what it is. So still at 100 watts. I feel confident leaving the power supply at 100 watts. I could run this at 24 volts, but the problem is I don't have a way to regulate it down. Just for fun, I'm going to pull out the temperature probe from the water. I'm just going to pop it on top of this resistor here. See how hot the top of the resistor is. 76C. Go right down at the bottom here. 70C there. You can sneak it underneath that sticker. 84, 80, 115, 122C. 130 something degrees Celsius, but the block here, yeah, I can touch that with my, actually feels cool to the touch over here. And the water is still 18C. So these resistors are getting crazy hot, but the block is holding up. So I think there's no point in continuing this with this load. We need to find a different load. Okay, obligatory, don't try this at home. This is a 40 watt grow LED, and this is the sort of thing that this could be used for potentially. Why don't try this at home? Well, got exposed live and mains here. I am using my DIY foot pedal test switch thing, so I won't have to touch anything once this is a go, but there's a potential for all the water to be live as well. So I'm not touching anything but these multimeters, which are properly isolated. Now this is a 40 watt, so I don't think it'll do as much heating as the resistors. However, it has more surface contact, so it might heat the block more. Also, so you guys can see, I have a welding glass, and also if something explodes, well then I get to get glass shards in my eyes. Alright, so turning on the multimeters. Another thing I have to note is that last time the resistors cooled down extremely quickly, so this system is working. But anyways, here we go. Oh, it's on. I don't know if you can see the shine over there. It's on, but the welding glass is not letting it through. See, it's on. Okay, and I'm expecting the temperature to climb a little bit, but it's not going to be as bad. So I can definitely touch the glass. That's not a big deal. Just going to space up the glass a little bit so it's not directly being heated by the LED. So same deal here. The surface temperature might be a little bit higher, but the water is taking a long time to heat up. Really, I don't even think it's necessary to run this whole system at its max power. The pump can slow down and the fans could slow down and it would still work just fine. So hopefully you see some of that magenta glow. See, it's definitely on, but I feel like I could probably run this ad infinitum without any issues. In fact, you know what I'm going to do? I'm going to set this to run, I'm going to leave it be, and I'll bring you back in a little bit. Well, it's been quite a while, about 15 minutes now, and yeah, this thing is bouncing between 20 and 21. This one here, the water temperature is 18, hasn't really moved. So I guess, you know, this is just fine. So this will work perfectly for the tech projects that are upcoming. Make sure you're subscribed for that one. And I hope you guys have learned a little something about building a water loop. And especially if that little something is that it's super easy and anybody can do it. So I hope you're excited for what's to come, because I sure am, and I want to thank you guys for watching.